afternoon. I am S.H. Lee from Department of Civil Engineering, Hong Kong University. I'm going to talk about as-is building information modeling from images. And I'd like to start with what is as-is in this title. So when we start create a building information model, right after design is done, the information model is defined as designed model. And after construction is done and building is delivered with the building information model, it is called as built model. And after building is delivered and start using, there are a lot of changes throughout the life cycle in operations and maintenance. A lot of updates, maintenance, repairs, and etc. So we kind of define this as is building information model in order to represent this is the model most up to date that has the exact information of the actual building. So I like to kind of introduce my research, how we can develop as is building information modeling, particularly from images. So this is outline. So brief introduction about the background, but I like to kind of skip a little bit details because the previous speakers already mentioned and covers a lot of background information why we need building information modeling, particularly existing buildings. He kind of covered the macro level, civil levels, but I'll kind of talk a little bit about the building levels or inside the building levels. And then two technologies I'm interested in order to process images. It's called hybrid fuzzy neural networks. And then another one is Mescal CNN, convolutional neural network system. It is kind of the deep learning algorithms used for processing images. And then another simple example is how we can use this as is building information modeling as operations. I like to kind of briefly introduce how we can exchange information from BIM to particularly estimate energy performance of the buildings. So in order to show BIM, how we can use this for engineering analysis, I chose energy model. And these are two specific details we need to cover. Make sure that they are properly modeled in the building information modeling, secondary space boundaries, and semantic enrichment. And then I'd like to conclude my presentation with some ideas. So not surprisingly, we are starting increasingly using building information modelings for new buildings. According to these statistical analysis and data collections, more than 70% already applied BIM-based constructions in 2015. So once the building is delivered, basically the owner already has BIM model. As we can see here, there are a lot of existing buildings built like 30 years ago, 40 years ago. Those buildings are maintained, operated and maintained using traditional information sets such as 2D drawings and text documents, hard copies, and etc. Some kind of pioneers who wants to create a BIM model in order to use state-of-the-art technologies based in BIM. They trying to create a BIM model for their buildings, but their technologies and methods they need to use are very labor-intensive and time-consuming. And obviously, it's a very costly process. But it's very important to have as-is BIM models. As I said, most of the expenses throughout the life cycle of a building is particularly on operations and maintenance, and having accurate up-to-date as-is BIM model is very important, and the first step to use these technologies. So researchers recognized this need, and then they started developing technologies. These are some of the common ones. The most common one is has been collecting point clouds using laser scanner, and then create surface models or solid models, as you can see here. Or this one. Or another way to create a BIM model is using images. So as the previous presenter showed, you go and take pictures and create a model by processing these images. Some of the limitations I recognize is still a lot of labor-intensive process, manual processes, and mostly focus on building geometries, either surface model or solid geometry models. And obviously, there is a lack of their topological relationship with the other building elements. So what I mean by this is there is a kind of the lack of information, missing information in order to make the model really smart. Otherwise, it's kind of very low level building information models. So I'm kind of interested in investigating and developing methods to fully automatically construct a geometry model from images, and then develop a method to identify semantic informations between those identified building objects, and then create a valid models at LOD 100 or 200. Particularly, I'm interested in IFC-based BIM model, which is industry foundation classes. It's international standards. And these are rough workflows. So go out and collect building images, and then identify and create IFC BIM model objects, and then assemble all of these and construct IFC BIM. And then lastly, use this BIM model to create an energy model. So firstly, image-based modeling. I'd like to start with the neural fuzzy algorithm. This study was started 2014, so it's about 5 years ago. And at that time, we thought that this is the most advanced algorithms we can use to process images. And later on, we kind of identified that deep learning-based algorithm is a lot better in terms of performance. So I'll kind of introduce these two. This is simple system architecture. So simply collect the informations from the images, and then recognize objects, and then recognize their materials, and then combine these together and create an IFC BIM model. At that time, when I started this research, we kind of had some difficulties to fully automate this process. So we kind of started with the semi-automated way. So this is examples. Take a picture, and we can easily see that there is columns, beams, and slabs, and floors, and etc., etc. So we kind of trying to identify what are the key features we need to use, and we identified that these are the necessary information we need to create, and then make the other process automate. So minimum interventions, human interventions, we kind of trying to create neural networks that has 5 layers, starting from input and then fortifications and the rules, and then identify objects with the probabilities, and then finally get the answers. For this particular research, we are interested in 5 different types of building objects. I'll show you later. It's column, beams, windows, doors, etc., etc. So for that particular objects, we thought that these are the necessary properties we need to use in order to classify the objects. And then we create a rule set. So for the column, for instance, it should be tall or very tall, and then near to the ground distance, and then near to the ceiling distance, and then it should be straight. So if all of these requirements satisfy these particular images has column objects. And for beam, another rule sets, doors, another rule sets, and etc., etc. And then we create membership functions, and then started train these membership functions with the sample images. So we collected about 120 images for each different types from basically campus buildings, and also downloaded from the internet and trained them, and then finalize these membership functions. So after we applied this, the computer was able to recognize objects. So as you can see here, for these particular images, we have a column, object 1, and we have a beam. This one, there is a door, and this one, there is a window and walls. So as you can see here, training was kind of tedious process, but the recognizing the result is quite fast. Almost real-time recognitions. And then moving on to the texture recognitions, we kind of follow the similar process. Collect some sample texture images and classify them into different layers. Then trying to identify key properties in order to recognize them. And then we tried images, and computer was able to classify what those textures are. And as you can see here, it has pretty high accuracy, precisions. So when we combine this together from the recognition of the objects with their dimensions and then texture informations, we can start create an IFC BIM models by following the IFC structure. And then this is the images created by IFC viewer that has this So once we have this promising result, we kind of move on to the next step, which is deep learning based. Just to briefly introduce about the Mescal CNN, that one was developed by computer science people and published in 2017. And what this algorithm can do is when we input the images, they can classify what these are. So there are people, maybe it can be luggage, it can be rackets, and et cetera, it can also localize where they are, and they can also segment these objects. So using these technologies and adopting their ideas, we created a neural network, and images coming from here follow these layers, and then eventually you know what the objects are in that images. And this particular one is fully automated. So we tested this with the images taken from campus buildings. So these are images from different loading conditions, lighting conditions, with some noises that we are not interested in. And we trained the networks with these different images, and then put these sample images for testing, and the results shows quite promising results. So this part is window, this part is wall, and there is a ruler in order to measure the dimensions. So we take these images and convert this to geometry models and eventually make a IFC BIM model. This is some data that we used. So for the training purposes, we collected about 600 for doors, 400, lift 34, and ruler 99 images used. And for the testing purposes, make sure that it produced the accurate prediction. These are the image numbers. And then when we put these experiment images, we have pretty promising results. So for walls, about 97.3% accurate. Doors, lift, rulers, no problems. And overall, 98.5%. So once we have IFC model, then we need to make this model proper BIM models, particularly for the energy analysis. So in order to put this model in energy simulation tools, these are the input structures we need to satisfy. And we need to combine these, map this to IFC model so that we can convert IFC 3D geometry model to energy model. And we need to make sure that we have secondary space boundary models in order to use Energy Plus or some other energy simulation tools. So this is IFC structure that are relevant to this information exchange. And these are additional informations we need to make sure that that has in the IFC model. And then following these 5 steps, we make sure that the model has all the necessary information in the IFC models. And these are the categories. When we complete the first steps, these are the information entities, and then this, and fill in this, and then the other remaining ones. So based on this method, we tested this with the simple 2-story buildings. That one has 65 virtual surfaces that covers fundamental building elements such as walls, slab, windows, doors, and roofs, and some shading elements. And results shows quite accurate, promising results. So we can use this for energy analysis. So I'd like to conclude my presentation with these some messages. The algorithm we used and developed has very promising results. Some of the challenges or research directions I have is extracting meaningful information from the images, such as precise dimension data. And then it's very important to identify semantic relationship information among these objects and make this fully automated. And eventually develop building information modeling libraries with these functions so that we can create our own BIM libraries that can be used for many different applications. In addition to not only just the energy simulation models, but also very general operations and maintenance activities. And maybe it can be used for first responders, emergency situations. So I'd like to kind of conclude this with my acknowledgement. This study was supported by RGC, and these are the students who helped me to produce these outputs. And this is reference. Thank you very much.